10%.
I don't care.
Do you see the idea?
Yes, physics is not the.
Repeat it again.
What happened?
You make me tired.
What did you say?
Go back to sleep, KJ.
This is the last lecture here? Waves?
Then
No,
what, they
there's two.
Oh my gosh.
No, but not today. This today, this Monday.
Okay.
What about chemistry?
Again, not caring about this since I don't teach it.
Oh, okay. With physics. What about physics?
I think I teach physics, so yes, I care about it. And maths. Chemistry, biology, EAP.
One thing.
You should care. I don't.
No. About maths and physics.
Yes, what about it?
Like we have like 12 classes, maths and physics in total last week, right?
If you say so. I believe you, yeah. So what's your point?
Around 10 maybe.
Whatever, yeah.
We don't have like ESAP or EAP in the last week.
Correct.
So we can do extra math.
If your teacher wants to.
I'm just asking.
What?
If you want to, do you?
Not really, but if I need to, I will.
What?
He wants extra maths and physics for the last week.
We need, not you.
Last week. Last week?
Your friends.
You don't want?
The week before the exams.
That's next week.
Yes.
That's next week.
No, that's the week after next, isn't it?
Yeah.
Yeah.
So that means the exams in 3 weeks.
Yeah, so Fahad wants extra revision classes.
No, I just want to go home and
Oh,
stay
need your vision. Amanda, you go home, sleep.
until exam. Yeah, and finish.
I
and
don't
be
know.
done.
Yeah, I don't know if this is the best thing to do.
Don't
We
worry
can
about
We'll
Seems
talk
like
about.
a cool
You
thing
shouldn't
to do.
talk to me when I'm hungry because it doesn't make me want to do extra things.
Are you hungry?
A little.
Meat.
No, thank you. All right, this topic next. Inference. So, well,
I can see there.
interference. Sorry, I was mixing up with a statistics word. Interference, not inference. Interference.
Experience. So does that mean?
Okay, we'll get to it. Don't you worry. Can I go on? You have this?
Yeah, sure.
Yeah.
Oh my gosh. State of news.
Okay, so definition. Interference is when two or more waves combine to form a new wave. So first, this part. Yeah.
Yeah.
So it's also the way that they add together is called the principle of superposition. Now the principle states it's kind of complicated. The net amplitude of the new wave at each point is the sum of the amplitudes of the individual waves. Now that's very technical, and basically, well, I'll write this down first before I get to the basic meaning.
And I did that principle of suppression.
Oh yes, the whole thing.
On this one dimension or two dimensions now or not?
It's kind of like two, but they go together. It sure is. Next. So hungry.
To buy something.
Huh? Just had soup. And I forgot I had yogurt in the fridge. I'm thinking about it and I want it. No, my yogurt's nicer.
No.
I don't like this yogurt. Muller Light blah.
Why?
It's light. I don't like light yogurt.
Why do you like it?
I want fatty yogurt,
Oh, fuck it.
not light yogurt.
I'm starting a new diet, only soup type.
You get fat.
Pleasure.
You eat fat yogurt.
Don't care.
Okay.
Delicious.
Why
Okay.
low fat.
Yeah, low fat blah. Nobody likes this.
I
All
like
right.
the original.
Original, yeah, better.
No.
No.
You know how to make yogurt?
Don't care.
My
Just want to
father-
eat it.
My father know.
I know.
Original is the
Yogurt.
very low
Cheese.
taste.
Really?
Oh.
You're crazy.
Go on,
Crazy talk.
You can try it.
Crazy talk.
Yogurt drink,
Let me
right?
size.
What?
You mean
Just
yogurt drink?
maybe 2
Yogurt.
nine
Yogurt or yogurt drink?
9.99.
Zavadi?
About €2.
That's
Yeah,
expensive.
you have to put some, a little, you have to make a
Two
little
kilos
zavadi
family
and
size
with milk.
yogurt.
Okay.
In
And then you make
very
it.
cheap. Illegal.
Yeah.
Remember completely, right?
Huh?
I don't
Yeah.
think it's very
You
cheap.
need a little yogurt on the first, right?
Okay. So basically what this means is the heights add or subtract together. So let me show you with a picture. So for example, look carefully. Here's wave 1 and here's wave 2. When they come together they make this.
Wave three.
So for example here, this wave goes down, up, down, up, down, well up, down, up, down, up, down. And it's very small. When you add it to this wave, it will go up, down a little as well. And you can actually, if you want to do it, look. See here, this height, you see here? This height plus this height
Okay.
makes this height. The heights add together. So another way to think about it, if I just draw it here on the side, if you have this wave and then you have something like this wave, what you can say is the height here
Plus the height. here.
plus the height here, that will make a very big height.
And now that
And then the other one, the height here, but this one goes down, so the answer will be something smaller.
Subtracted.
Subtracting then, yeah. In other words, it's not a surprise that you add the heights to get the new height. That's all.
Okay.
That's no surprise. That's called the principle of superposition.
That's okay.
Yeah,
Not
it
bad.
makes sense.
Yeah, makes sense.
note it down.
You can draw the picture as well if you want. I can go on?
No.
Oh my goodness.
You said note it down.
Or draw. Oh, that's beautiful.
A class.
A minus.
No.
Got this?
No.
Okay. Mhm.
A class. Wonder.
Okay.
Wonder.
Okay.
Wonderful.
Can I go on? Yeah. Okay. So, a little bit of vocabulary. Two waves are coherent if they have a constant phase difference and the same wavelength. So I can show you here with the picture. If you look for a moment, the wavelength here is the same as the wavelength here, the same wavelength. But if you notice, here's the peak here, and here's the peak here, and there's a difference between the peaks. Here's the peak for the bottom wave, here's the peak for the top, and it's the same difference. Here's the peak for the top, here's the peak for the bottom, and they're the same distance apart. This means coherent.
It's the same.
The same distance between the maximum and the maximum, they're the same distance apart. So for example, if I draw it, look. Oh, ugly, ugly, ugly. Yeah. If you look here, here is the trough, and here is the trough, and then here is the distance between them, for example. And here is the trough here, lowest point, trough. And here is the trough here, and the distance between them is the same. Or look, here's the peak here, and here's the peak roughly here, and the distance between them, they're all the same. When this happens, we say they are coherent.
Coherent.
Yeah.
It means here
The same distance apart.
I mean, this could actually be that wave, but another wave.
It could be the same wave as on top, but delayed.
Yeah.
Yes. And in fact, often that is the situation.
I'm just
You're doing no, don't translate in my class. I don't like translation.
okay, so give me the spelling of trough.
Of what? I
TROUGH.
gave it to you last.
Trough.
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 T
R
R O U G H.
What's that?
Like the bottom part.
The lowest part of
The
wave.
lowest part of the. I did this in the first lesson on waves. All the names. Remember peak and trough,
Crust.
crest and trough. Yeah. Ah, whatever. They don't, because they don't do their homework or revision. Okay, next. Next.
Okay, next.
Yeah.
Go. Go ahead.
I'm just waiting for KJ. I'm just waiting for KJ. Yeah. Next. Yes. Okay.
I drew the wrong one.
You can fix it later.
Uh,
Yes. Next. Now, when two coherent waves move together from two different sources, eventually they will meet. We say the path difference is the difference in the distance each wave travelled. So I'll draw this with a picture. So look, before you write, let me explain it here. So here is the first wave, and it travels a distance, and then its peak meets the other wave that travels here. We say the path difference is 0 because each wave travelled the same distance. Now in this picture, which wave travelled more? Wave 1 or wave 2?
Wave one.
Wave 1 travels,
More than.
wave 2 travels, and the path difference in this example is some number, it's not important. But the path difference is the difference between S1 minus S2. It's S1 minus S2 is the path difference. So here the path difference is 0 because they each travel the same distance. And here the path difference is not 0 because S1 is bigger than S2.
What if they're going straight?
What do you mean? Oh, if they're together? Yeah, if they're together like this, like here's the first wave, for example, and then let me draw the second wave. Maybe, for example, it's like this. I don't know. It's I don't know what I'm drawing. But let's say here, it takes blue travels this distance. I guess KJ it'd be 0 as well, because they both have to travel the same distance for their peaks to match. So it doesn't really make sense if they start from the same place. We always talk about path difference being from two different sources.
No, not that. As in
Oh.
they're from two different sources and they're parallel.
Well, these aren't parallel here. Oh, no, they must meet. If they're parallel, then it doesn't work. Path difference is the difference they travel to meet. Yeah. So this is path difference. In this example here, the path difference is half a wavelength. Shopping? Nah, not today. I'll wait until I have money. Not today. I don't know, I don't have much money. Let's see how much I
It's
got.
end of the month you're receiving your salary.
Got 10. Not
See,
much.
you have credit cards.
That's not a credit card, that's a debit card.
So
You need to have money in the account to use it. It doesn't work if you have no money in the account.
But you have, at least you should have, like, you have one credit card.
I don't know why people keep thinking I'm rich. I have no money. What are you talking about? You see me bringing my cheap coffee I make myself to class.
What?
You see me bringing the coffee in the white cup, yeah?
But still,
I make myself for free.
but you're a
I
teacher.
don't think so.
Yeah, I'm a poor teacher. Poor teacher with no money. A hungry, poor, tired teacher.
You broke my heart.
Yes, it's true. It's all true. I'm hungry and I'm tired and I'm poor.
You
And
monster.
no money.
Yeah, no money, no money. My students, the students make me tired. Oh, it's terrible. All right, you've got this. See what I mean?
Frightened me.
You spend your whole day traveling, working.
But when I came to your house like on last weekend,
Yeah.
I saw 2 cars.
Did you really?
Yeah.
You don't even know where I live.
Oh, 2 cars?
No, it's wrong actually. One
You
car.
have a Honda
I
Civic.
have car.
Yeah,
It's not poor. Yeah.
I'm just a poor farmer teacher from the country.
Not for
So you have a car. Why are you using
Yeah.
the bus?
You have a Honda Civic.
So I can sleep on the bus. I can't sleep in my car. Yeah.
No.
Try once.
No, please.
Oh, come on.
Just
Well,
for one
time's
try.
running out.
Ah.
Time's running out.
Yeah, we'll give her 5 more seconds. Yeah, 5, 4, 3, 2, 1.
No, it's
Ah.
still space. No.
Quarter. Zero.
No.
200 milliseconds. 100
Yeah.
milliseconds.
Bye bye. Give up.
Okay, give up. Good. Right
Okay. Bye
now, just there are 2 types of interference. We say constructive. This is when the waves come together to make something bigger. Destructive is when they combine to make something smaller. And completely destructive is when they cancel.
Cancel each other.
Yeah, so look, here's some pictures. This one is destructive because the waves, when they add together, there's no wave. Whereas this one is constructive because when they add together, they make a bigger wave.
Write that down.
Well, no, Karar, you don't have to if you know the difference between constructive and destructive in English. Do you know constructive and destructive?
No, it's
Better write it down then.
three types or two types?
Well, there's only really two. The only difference in the third type is the extra adjective completely. Yeah.
Is there any difference when you say cancel each other or you say cancel each other out?
No, no, it's the same meaning.
Same thing.
Yeah.
But this is most like stronger. You said out.
No, it's just I guess if I said when the waves cancel each other, it feels like the sentence is not complete. So this is why we usually put the word out at the end. So I don't know what the word is in English or in grammar, but I feel like without the word out, something is missing in the sentence. When the waves cancel each other out. Also, cancel each other out is kind of like a phrasal verb.
Yes.
You don't really break it up, you know. Cancel each other out is actually almost like one phrasal verb. You know what I mean when I say phrasal verb?
Yeah.
Yeah.
Of course, yes.
So out is usually in there. Although it's not necessary, you can drop it. It's still okay. Alright, next. Yeah. So this is a very important type of experiment which I'll actually draw for you. And it was done by Thomas Young, I think a long time ago. So what he had was, in the window, of course the sunlight was coming in. And what he did was he had a piece of card with a small hole in it. So, you know, the sun would be quite bright, so there's lots of light. But by having the small hole, he gets just a little bit of light
Diffraction.
come out like this. And what's this called?
Diffraction.
Diffraction, when it spreads out. Yeah. Then what he did was he put another card here, but this one he had two holes in it like this. So the light comes along, and then it goes through the first one, so it spreads out. Then it goes through the second one, and it spreads out. Now, in red, let me call that the maximum of the wave, and then in blue, let me call that the minimum. And what I mean is, when you think about the wave, it has a maximum, and it has a minimum, yeah? So between the maximums are the minimums. Now look here, look. What happens when the maximum here meets the maximum here? It'll be a bigger wave. And what happens, for example, when the minimum here meets a maximum?
Should just be medium wave.
It'd be no wave.
Oh yeah.
So, for example, here, if a
Like opposite.
one wave, two waves. If a maximum meets a minimum, then there's no wave.
Yeah, like 2 minus 2.
Yeah. So what's going to happen here is when the maximums and maximums meet, they make a bigger wave, and when a maximum and a minimum meets, they cancel. So when you look at the screen, some parts of the screen are very, very bright, and some parts of the screen are very, very dark. And this is because they're bright when the two maximums meet together, and it's dark when a maximum meets with a minimum, and they cancel. So this was Thomas.
What about a minimum with a minimum?
Why do you have to complicate my life? A minimum with a minimum would be very minimum. Yeah. So there'll be some light.
Yeah, but
Yeah, there'll be light. But there's only darkness when a max meets a min. Otherwise, there's light. Yeah. So this is what's happening. You got light, dark, light, dark, light, dark, light, dark.
We can try this.
You can do this. You don't. All you need is two cards. One card with two holes, and then another card with one hole. In my picture here, it's just a light bulb. Of course, Thomas Young did not have a light bulb 200 years ago. Okay, but it's the same idea. Now, this picture you get here, this is called a interference pattern. The picture of the light and the dark. This is an important word. Interference. Also, We don't call them light dark spots. They have a special name. We call them fringes, which means light dark spots. Yeah. Please write this vocabulary down.
Like what?
Yeah, really, it's.
Like Starbucks?
Oh my goodness. Now look. This here, dark, light,
Yes.
in English you would call these dark spots. Yes? In physics we don't call them dark spots, we call them fringes. But they mean dark spots. And this picture, we don't call it a beautiful picture of light and dark. We call it a interference pattern.
How to draw it?
You don't need to draw it, it's okay. Just once you have the picture in your mind. Can I go on? Go ahead.
No, it's not pictures in my mind.
What's your question?
No, this is, I'm just asking, if we have a light,
Yeah.
it's, you said a hole. Okay?
Yeah.
If it's a hole, it's direct light source.
Yeah.
So it will be like, it will look like this.
It will. It will. You know when a wave passes through a slit, it diffracts and spreads out.
Yeah, I read it, but you know, when I see, like, for example, not here, in Riyadh, because you know we have like a house,
Yes.
from a window,
But the spreading out might be too small to be noticed. But it does spread out. No, maybe.
I'm
it
just
does
saying
spread out.
because you see like on the wall, on the corner, it's just a like
This one is-
round circle.
Yeah, I know. But the round circle will be bigger than the hole if you measure it because it spreads out. You're just judging by your eye. This is not how we do
That's what
physics.
it's asking.
Maybe this is how we do biology.
No.
No, but not how we do physics. All right. Next.
It's like,
No.
Yeah, I don't. Yeah, no, it's okay.
Two faces coherent.
Yeah, look, listen. You don't need to write all of this down. What you need to write down is the title. 2-point source interference pattern. 2-point source interference pattern. 2-point source interference pattern. Yes?
Do we have to explain it?
No, I'm going to explain it with a picture.
Do we have to draw the picture?
Yes, please draw my picture. I will draw in a moment.
Like in exam, we have to draw a picture.
Maybe.
and use.
Did you write the title down?
Yep.
Okay, can I go to the picture now? So look, what I mean by 2-point source interference is this. Look, here is a source, and here is a source, S1 and S2. This could be a sound wave, doesn't matter. It could be a sound wave, it could be a light wave, it could be a radio wave, doesn't matter. This picture is called 2-point source interference pattern. It's when the waves come together to make bright, dark, bright, dark. Now listen, question. If it is light, it will be bright, dark, bright, dark. If it was sound, what will it be? Loud, quiet, loud, quiet. You get the idea? Yep. Okay. Let me draw. I just did. Okay. Can I go on? Yeah. Okay. A diffraction grating is just a piece of plastic with many long holes in it. Here's a picture here. Now you don't need to write this down, just the name, diffraction grating. So you see here, You see the way it has lots of little holes in it? You see that?
Yeah.
You can see through it. These holes are not called holes, they're called slits. That's an important word. Write that down, slits. They're the name of these holes. Can you see them? The long holes. See, there's a long hole here. This is called a slit. These are called slits.
Slits.
When you have them all together, it's called diffraction grating. That's the name of this. So in fact, look. This is one here. Look.
Okay.
This is a diffraction grating because it has lots of slits. So this is actually one.
Right there.
Well, I think it's to stop you from killing yourself, really.
How can I kill?
Well, you know, if you stick your head in it or something. Yeah, your head. Yeah.
Yeah, it's my
Yeah.
idea.
There's plenty of stupid people in the world.
I wanna try. No, for children they use that thing.
Yeah, stupid people. Yeah.
Children, not stupid.
Well, they are, because they're inexperienced. It's not a bad thing. Alright, have you got this?
Yeah.
Yeah, okay. So just some vocabulary.
Slit.
So the slit separation is the distance between the two sources. So if you look here, that's what I mean here. That's called small d. Actually, you know what? I'll draw it again. So here is S1, here is S2, and here we have bright, dark, for example, bright, dark, and here dark, bright, dark. Okay, so the first thing I did was, this here is called the slit separation, which is D. The fringe separation S is the distance between the fringes. So that would be, well, it could be like this. That's S, that's S, and so on. Or if you want,
From
it's the,
one red to one.
yeah, or one dark to one dark as well. They're the same thing.
Okay.
That's S. That's called the fringe separation. Okay. Next is the angle theta. So what you can do is, here you can draw lines to, whoa, that's not a line. So this here is what I mean by angle. Angle to the fringes. So the next one here will be a bigger angle. So that's what I mean by angles. It's the angles you could have here. So this is the angle to the first one. Then this one here is the angle to the next one. So the angles get bigger. Then you have the next one, bigger angle again. So the theta is the angle. The distance to the screen, that's no surprise. That's this distance here. Big D. And lastly is the order, n. So this is the order here. This first dot I call n equals 0. This next dot is n equals 1, and this one here is n equals minus 1. This one here, n equals minus 2. This one up here, n equals 2. This is called the order. So this one here is the first order. This one here, the second order. This one here in the middle, zeroth order. So that's the order. So you can write it down or you can draw it. I don't mind. You want to draw it?
No, I want to write it.
I'm going to put the video up tonight so you can watch. You can pause the video.
Yeah.
Not
Good
today.
idea.
Maybe Sunday.
Maybe before exam.
Question.
Yes. She needs your help. What? Assessment for
Mass assessment.
Yeah, I
Yes.
haven't started.
Listening,
I
listening.
haven't started the maths. What, listening?
Listening
No, the
assessment.
What about it?
I don't know what it is.
I don't know either. I really don't know. You'll have to talk to an English teacher.
You're an English teacher.
I'm a PFE English teacher.
What's
That's different.
There's a mass listening test.
No. Go back to writing this down.
Listening. No, what?
Assessment.
Assessment. I understand this word, assessment.
I know.
And I know listening.
I know,
Yes.
but you don't know what it is.
I don't know what it is because I don't do it. Yes. Yes.
Because Grace she don't go to the class. I mean, so she don't know that.
This is the real problem. One class is enough. The dot number 0, 1, 2. Can I go on? Look, we're boring KJ. He has nothing to do. Can we go on? Yeah, put it away, KJ, if you want to keep it.
Take it off. Take it off.
Throw it out.
I'll give it to you, you can sell it.
What type of phone is it?
iPhone.
Which one?
1.5C.
Garbage.
It's better than Motorola.
Ooh.
My phone is a beautiful, wonderful phone.
It's a lady's phone.
Watch this. Watch this.
Samsung.
How often do you charge yours up?
You just have the same.
How often?
Oh,
Every day?
obviously.
Every 2 weeks.
Do you have WhatsApp? Do you have Facebook? Do you have internet?
Don't care about Facebook.
Do you use Facebook?
Yeah, once per year maybe. Yeah.
For a year.
Okay, next. Yes.
Yeah.
Yeah. Okay. So for these problems, you have 2 formulas you can use. They are m lambda equals d sine theta, and s equals lambda big D over small d.
And lambda equal d sine theta. S approximately.
Yeah. Now the second formula really isn't equal, but it's very accurate, so it's okay to use, and in fact, it's fine for the exam. Okay. Have you got those 2 formulas?
Yeah.
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 Can I go on? Yes.
Yep.
All right.
Oh.
So we have one example. Now you don't need to write it down because I'll draw it. It'd be easier. So what you have is here. You have a room,
Yep.
and there's some sound coming out, and the sound frequency is 2000 hertz. And in the room, there's 2 doors or 2 windows. We can say they're 2 windows, it doesn't matter. And the distance between the windows is 1 meter. Then what happens is there's a boy walking along here on this wall. And as he walks along, the sound gets loud and quiet and loud and quiet. And what's happening is when the sound comes out of the first window, the sound comes out of the second window. Like we saw, sometimes they'll form a peak and sometimes they will cancel. Also, I can give you the speed of the sound is 330 as well. And the distance here is 2 meters. So my first question is, as he's walking, he'll hear loud, I'll write it like this, loud, quiet, and so on. So my question is, what is the distance between the loud parts? So if you go back to your formula, it's the second formula. What's the second formula? Yeah, that's S. S equals lambda d over small d. So lambda, you need to calculate it here by using this formula, V equals lambda f. because you know the lambda and the f. So can someone give me the lambda, please? Now, what's the big D? 2. And the small d? 1. So can someone give me the lambda? It's 6, 6. No, that's not it, Fahad. What is it? 165. So what's the answer here? The answer here is 0.33. So it's 33 centimeters.
Why is this 2 over 1?
The formula, big D over the small d. It's the formula I just gave you a minute ago. Okay, what is the angle to the second order? So if you look here in the center, it will be very loud. That is n equals 0. Then it will be quiet. Then it will be loud. That's it, n equals 1. Then what's next? Quiet and then loud again. That's n equals 2. So my question here is, what's the angle? What formula? The first formula. D sine theta equals n lambda. Yep. Quick, there's not much time. What's your question? Chop, chop.
You have to go like, even, you cannot go loud or stop.
No, the answer, it's always allowed in the middle.
It's a fact.
It's a fact.
Loud is not.
Yeah, yeah.
And it's anything to
And in fact, it is the loudest part of the loudness. It's the most loud. Anyways, what's the D here? Small d. 1, small d. Sine theta. What's the n? 2. And the lambda? 0.165. So theta is sine inverse 0.33. What's the theta?
19.268.
About 20 degrees, we'll just say. Whatever, roughly. I'm pushed for time. What is the maximum order? So what's going to happen is the maximum, well, what's the maximum angle? Could be nearly 90, couldn't it? So if I put in 90 equals n lambda, I want to know what the biggest n can be. So n would, that's gone. N is equal to d over lambda. So what is that, please? 1 over lambda, 6.06. So the biggest one is n equal to 6, because if I go past that, I get 90 degrees, which obviously doesn't meet, it just goes straight. And the last one is how long? So in other words, what's the distance to n equals 6? Well, that's not so difficult, because I think it will just be 6 of these. Because it'll be loud, quiet. So there's 6. So what's that?
1.98.
So it's for about 2 meters then. Now what's really nice is on Monday, when we're in D207, there are 2 speakers in the room. There's oh no, I got them working.
Okay.
There's a speaker there and there. So what I can do is I can play a sound from both speakers, and you can walk along the back of the room, and as you walk along the room you will hear it going loud, quiet. Even though I'm not changing the volume, it's the same sound. It just hums, it goes but as you walk along the back of the room it goes because the 2 waves are crossing or cancelling. You'll be impressed, I promise. Okay. All right.